Hello, I'm moving along with the next stage of my radio controlled transmitter project, which is going to involve one of these things here. This is a sensor module, and it costs a little bit more than the average sensor module that I'm used to, which is usually a few dollars. But this one was the pricely sum of $10 from, yes, of course, Banggood. And what it is, it's quite impressive really. It's not much bigger than a fingertip, but on here we have maybe you can even read them now that I have a camera that focuses properly. We have a 3-axis accelerometer and a 3-axis gyroscope and a compass and a barometer. So that is quite a lot of sensors. Plus we have some nice mounting holes. And all of the data from this can be read through just 4 pins. Plus, you can run it from 3 volts or 5 volts just as happily. I'm using 3 volts here because I have a 3 volt Arduino attached to it. And this is just an Arduino Pro Mini, and I have a battery and an nRF24 module that is doing some transceiving. That's right, transceiving, not receiving or transmitting. It's doing both, because I finally figured out how to do transceiving with this thing without it being extremely slow. Like the first time I tried it, I was trying to change between transmitting and receiving, and that just was way too slow. So the other side of this equation is this thing here, and this is my trusty testbed thing for testing radio communications, and it's just another set of the same things plus a OLED screen. And what we have showing on the screen here is the first 2 numbers at the top are the number of packets that have been transmitted and received respectively since the screen was last refreshed. So that's 1 because I'm doing a screen refresh every time through the main loop of the Arduino code. And the 0 to the right there shows how many transmissions have not been acknowledged. So we want that to be 0. The number below that is the altitude according to the barometer on this sensor. It's the relative altitude to what the altitude was when it started, when this side was first turned on, that is. And over to the left you can see some tick marks on the side, and those are, I forget, I think they might be 5 meters. They represent 5 meters of vertical height for each tick mark. No, I'm sorry, 2 meters. 1 meter. Must be 1 meter. And the little tick that's moving up and down is showing where the altitude is at the moment. That's why so you can see it's going down minus 1.6. So those ticks must be 1 meter, I think. Yeah, I can't remember what I set them to, but they must be 1 meter. So you can see at the moment it thinks it's minus 1 meter in altitude from the point that it started, which is not quite right. So I'm not sure why that is, but it's usually a little bit better than that. Okay, and then the 3 lines at the bottom are the fun part, because they represent the pitch, roll and yaw of the sensor module on the other side of the radio connection. So to demonstrate how they work, I'm going to have to hold this a little bit awkwardly, but let's see. Okay, so if you imagine that this is a aircraft or a quadcopter, as I'm hoping to put it on, and this part is the front of the quadcopter, so it's flying that way. When I rotate it when it yaws, you can see the middle line on the screen is rotating with it. So if I try and line them up, let's see if I can line up. So now the middle line on the screen and the sensor module are approximately lined up, and if I turn them around, you can see that the line on the screen follows the sensor module. And I can't really twist my hand all the way around, let's go like this. So you can see it follows pretty well. So that's the compass doing its job. I have to give a lot of credit to the guys that programmed the code to get this data off, because I didn't have to do any programming for that really at all to get the sensor fusion and stuff working, and it works very well. The response is good. This screen is only updating at about 20 frames per second. I think that's as fast as it can go, but this radio transmission can go much faster than that, and so can the sensor. So when this actually gets into its final home on the quadcopter, the transmission is not going to be 20 frames per second, it's going to be more like 300, as I'll show you shortly. So anyway, that is the compass doing its thing, and you can see it's fairly quick. Okay, so the other two lines that we have, the one at the bottom is the pitch. So when the quadcopter goes to lean forwards, it's a bit hard to see in the video, but you should see that line moving one way or the other when I pitch backwards and forwards. And the one at the top line there is for roll. So when I roll the IMU this way, we can see it turning that way and that way. So I might just see if I can reset this altitude so we can see that working a little bit better. So I made it so that when it first starts up, you can see it says init, and it's just taking the average of the altitude readings it gets for about the first 200 readings, and then when it switches to alt, now it's showing the relative altitude to where it started. So this is a lot better. It's within 10 centimeters of where it started. Okay, 30 centimeters, whatever. But it's roughly around 0, you can see. And if I take the sensor and I raise it above my head as far as I can, you can see that the altitude is around about 1 meter. So that's 1 meter higher than where it started. It's not very constant, it sort of bounces up and down a little bit, but I've never really seen it go more than, it usually stays within 1 meter of the correct result. So I'm quite impressed with that. I can't really complain for $10. Now if I put it down on the floor, hopefully we'll see it go below 0. Not much, but good enough. So it's, got to -1. Okay, so I think it's about 1 meter below where it started, so I think that's pretty good. Yeah, so that's the first part that I thought was pretty cool of this little project. But the other part that was actually much harder to do, so to get a rough comparison, pulling this data off the sensor here, as we've just been looking at on the screen, took about an hour and a half, I think, to put it together. But sending the data back from this side to that side actually took me about 2 days to figure out. There was actually a problem in the nRF24 library which I had to fix a little bit, and I posted I made a post in the Arduino forums which I'll put a link to in the description, so you can check that out if you want to know the details. But what's actually happening here is the radio on the sensor side is not simply transmitting data to this side. What's happening is this side is initiating the communication by sending just a dummy packet, essentially. I think it's just one integer that says 0, that's it. So it's not actually any data. So that packet goes from here to here, and then this one writes all this information that we're seeing on the screen from the sensor into the acknowledgement packet that automatically gets sent back to this side. So hopefully, if you understood what I'm saying there, you can see that this is extremely useful, because now we have a bidirectional link between these two radios that runs quite fast. And as I said before, when I first started playing with these chips, I tried switching them between reading and writing mode to try and get this bidirectional link, and it was extremely slow, but this is much, much better. So, of course, what I'm planning to do with this is that this side would be my radio control transmitter, and instead of just sending a packet that's an empty packet that just says 0, I would be sending the control inputs from my transmitter sticks as I control the helicopter. So all that information will be going to the helicopter as I've already done, and that seems to be working okay. And then the helicopter would be sending back this information from the sensor, so that the transmitter on the ground will have all the telemetry information to know the orientation of the quadcopter in the world and the altitude of it as well in real time. So that's the goal. And just to look at the speed, I'm going to have to quickly just change the program a little bit on here. So that instead of updating the screen every packet, we'll only update the screen once per second. So now you can see it only updates once per second, and we're getting a bit over 300 packets per second. This is using 1 megabit per second data rate. I'm not sure if I want to use that, because you tend to get better range with the 250 kilobits per second data rate. And that would be 1/8 of this, which is still about, you're still getting about 80 packets per second, I think. No, more like 50, isn't it? Yeah, whatever. I think it was something like 50 to 80 packets per second at good range, like about 700 or 800 meters. Of course, I won't be using these low power chips. I'll be using the high power chips with the antenna. But if you do the calculations here, sending 300 packets both ways of 32 bytes per packet potentially is a pretty good data rate. I think it's 9 kilobytes per second. Bytes, that is, not bits. Kilobytes per second in both directions. So I'm pretty happy with this outcome so far, and looking forward to trying to get it onto the quadcopter and get some results while I'm flying. And fortunately, like I said, it only requires these 4 wires here. So you just have the ground and the positive voltage, and then you have the 2 I2C lines, and that's it. So all this other stuff I already have on the helicopter, so I don't need to add any of this stuff. So all I need is 4 wires onto the existing Arduino that I already have on the quadcopter, and we're ready to go. So hopefully I can get this working and make another video about that when it's done. Alright, thanks for watching.